Before we see how place value sections and expanded notation for multiplication can help us with division, I first want to review how we use place value sections in multiplication and also expanded notation in multiplication. So if we had a problem like 326 times 3, we would first expand 326 into 320 plus 6, and the 3 would just remain a 3. And then we would go through each section and find the partial products. So our first problem would be 3 times 300. And our answer to 3 times 300 would equal 900. Our second partial product would be 20 times 3. 20 times 3 would equal 60. And then finally, 3 times 6, which would equal 18. Expanded notation is a lot like our place value sections, except instead of using that area drawing, we're just writing down the numbers. So we have 326 times 3, and we start by expanding the 326 into 300 plus 20 plus 6, and we just have a 3. And then we're writing down our multiplication sentences just in the same order we did them in the area drawing. So you'll start with 3 times 300, which is equal to 900. 3 times 20, which is equal to 60. And finally, 3 times 6, which is equal to 18. And then you'd finish by adding up all of our partial products. So it's the same thing as our place value sections, except we're not using our handy little area drawing like with our place value sections. We're just writing down the work. Now I'm going to show you how we can use the place value sections with dividing. We're basically going to work backwards to find our quotient instead of finding a product like we would before. So we already know the product and we're working backwards. So our division problem is 738 divided by 6. We're trying to find the quotient, but we already know the big number or the product is 738. We know the area, the overall area, but we have to work backwards to figure out what numbers we put in our hundreds, our tens, and our ones. Our divisor is 6. Our dividend is 738. So for our first box, what could we multiply 6 by that ends in 2 zeros like we have in our hundreds section? That ends in 2 zeros, that would get us close to 738 without going over 738. So if we multiplied 6 by 200, that would be too big. That would give us 1,200, right? 6 times 200 would be 1,200 or 1,200. That is too big. So we know that it has to be smaller than that. So let's try 6 times 100. Well, we know that 6 times 100, we know that 6 times 100 is 600. That's not too big, but it's pretty close to 738. So we know that this has to be a 1, and now we can start subtracting or working backwards. 738 minus 600. So 8 minus 0 is 8, and 3 minus 0 is 3. 7 minus 6 is 1. Now we are left with 138 to continue to work backwards. All right, what would get us close to 138 times 6, but not go over 138? So we're trying to find that number. So if we took 6 times 30, we would get 180. That is too big, so we know it has to be smaller than 30. Let's try 6 times 20. 6 times 20 would be 120. It's smaller than 138, but it's still close to 138. So we know that this number here has to be a 2. And then we're going to subtract that total, or that partial product, from 138. And we would get 18. Now 18 is our final partial product. Well, we know that 6 goes into 18 evenly. 6 times 3 would be 18. So at the beginning of this problem, we knew the divisor and we knew the dividend, but we were looking for the quotient. Well, right here is the quotient. Now, all we have to do is change this from expanded form to regular form. We just have to make this 100 plus 20 plus 3 into our normal way that we write numbers. So if we change this from expanded form to regular form or standard form, we would have 123. So our answer, or our quotient to this problem, would be 123.